participated in that contest yesterday? Can you say it one by one? Just raise your hand or uh, write yes in the chat. Okay, so we will start now from the first question, uh, which is energy crystals. Okay, so basically in the div 2, the first question remains a little bit easy, and then the level increases. So firstly, I think you should read the question, or I will read it for you. So what is said in this question? So see that there are three energy crystals numbered 1, 2, and 3. So okay, there are three energy crystals, and let's denote energy level of the ith crystal as AI. Okay, so we are given with the energy level of the energy crystal. Okay, so initially all them are discharged, meaning their energy levels are equal to zero. So here it is said that at first, at t equal to zero time, or you can say at the first, and every energy crystals are having zero energy level. So each crystal needs to be charged to level x. Okay, and exactly x, not greater. So what we have to do, we have to charge the energy crystals into uh, level x energy level. Okay, and not less or not more. uh, and then what we have to do, in that case, in one action you can increase the energy level of any one crystal by any positive amount. However, the energy crystals are synchronized with each other, so an action can only be performed if the following condition is met afterward. Okay, so basically it is said that you can increase any of the crystal energy level of the crystal up to any positive integer or positive amount. And but it is said that in every action there is a certain condition which should be met. So what is the condition? The condition is that for each pair of crystals I and j, it must hold that ai is greater than equal to the floor value of aj divided by 2. Then what is the minimum number of actions required to charge all the crystals? Okay, so basically now we have to say that by following this method or this criteria, how much amount of uh, or how much number of actions we should have to do so. So firstly, what you should do, that you should check for one, two, or three test cases, so that you get a rough idea that what is happening here. So basically, if we say this is the input type, where the first line is the T, which consists the number of test cases, the description, and uh, thereafter the all the numbers here, they are the value of x. Okay, so this is the value of the energy level which you should make uh, in the three crystals. Okay, so if we see the explanation of first two test cases, so here you can see that if we want one uh, for each one level energy level for each of the balls, so we need three moves. For five we need seven moves. 14 we need 9 moves. So basically these are the minimum moves in which we can achieve our goal. So now if I do it for you, so basically what is there, there is three crystals. Okay, and and they are initialized with zero value. Okay, so there are zero in every crystal, and at any time what we can do, we can choose any of the crystals. Let's say we choose this crystal and we make it to any positive integer. Let's say we take it z. Okay. Uh, but one thing we should keep in our mind that if we make it z, so there the condition must hold true, which is what, that a for any for each pair of ij, ai must be greater than or equal to aj by 2 its floor value. Okay, so what is ai and what is aj? Aj and ai are any of the crystals where I is not equal to j, so they are unique. Okay, so then if we try that, what is happening here, that if we want to increase the zero level into 1, can we do that? Okay, so basically if we try now, then 0 and pair that 0 and 1 pair, so 0 and 1 pair, then 0 is greater than equal to 1 by 2 floor value, and this is 0. Okay, so this equation holds true. And now if we check for that other pair, this pair and this pair, so again 0 comma 1 pair, and again it will hold true. Okay, so there, and at last this pair and this pair, so 0 comma 0, and if it is, it will obviously hold true because 0 divided by 2 is obviously 0. So basically we are sure that we can make it to 1. Now can we make it to 2, 3 or any other higher energy levels at that single time? So let's check. If we make it 2 instead of 1, we make it 2, then what will happen, that if we take this and this pair, so what will happen, that this must hold true, 2 must be greater than or if uh, okay, the okay, 0 must be greater than or equal to 2 divided by 2 and its floor value, but it is 1, and 0 is greater than equal to 1, it is not true. Okay, so basically it doesn't holds true for the criteria, and so we can say that we are unable to make the 0 to be 2 at a single time or any other greater value. You can say, let's say 3 or 4 or any other bigger value. So basically what is happening here, and now we'll check. Let's say a test case. Here we are given a test case that to make the energy level to 5, what we how much um, how much steps we need. Okay, so we will make 5, 5 and 5, and what are we initialized with? We are initialized with 0, 0 and 0. So firstly, if I thought it greedily, so what I will think, I will think that what is the maximum amount I can make from 0 at any level. If here is 0, 0 and 0, then I can make it 1. Okay, so that will satisfy 0 and 0. And now again, if I take 1 and make it, try to make it 2, I will be unable, as I saw you here, that if I make it 2 or any greater than value and the rest of the values are 0, 0, it is impossible to do so, as there is a criteria which you should abide. Then what is the problem? If we check that there is an simple observation which you can see, that if there are some integers, let's say 2 comma 3 comma 5. Okay, so how can we say that this pair, or you can say the triplet which makes 3 pairs? Okay, 2 3 3 5 or 2 5. So all the pairs are right, or you can say all the pairs are okay, and this maintains the certain criteria which are which is given. Okay, so what we have to do, we have to just check that the what is the minimum value here. The minimum value here is 2, and what is the maximum value here? The maximum value here is 5. Okay, so now if we see that 2 is greater than or equal to 5 by 2, and its float value. So what is that? It is okay. It is obviously 2. So and 2 is greater than equal to 2. It holds true. So basically, and now we see that for you can see that for each pair, the condition which is uh, ai is greater than equal to aj by 2, its float value will satisfy. And how we can see that? There if there is a condition, okay, ai is greater than equal to aj by 2. So let's say what will be the worst condition that it will not abide by with this criteria. Then if there is a maximum value, or there is a value which is the maximum in this triplet, and there is a minimum value which is let's say it is not 2, it is 1. So then what would happen? Then it would be that 1 is greater than equal to 5 by 2, its floor value, and it will not satisfy. Okay. So and if it satisfies here by 2, then what we can say, it satisfies for 2 comma 3, 2 5, and 3 5 also. uh, why how we can say that? We can say that for the worst condition, that is the we are taking the minimum value for the left hand side and the maximum value for the right hand side. We are getting that the criteria holds true. So basically here we can say that for each and every pair which can be formed will abide by the criteria. Okay. So up till it is fine. Now if we see it here, so what we are up to, we were making it to 5 5 and 5. So basically what we can do, we can do that for this triplet. Let's say something, it is a minimum, there is a minimum value min, and there is a maximum value. Okay. So you can say that say from there that there it holds true for 2 comma 5, there where 2 is the minimum value and 5 is the maximum value. If there would 5 or there would be 6, then it would not hold true. Okay. So basically what is the criteria that it holds true for the triplet? The criteria will be that the maximum element should be greater than equal to 2 into minimum plus 1. Okay. So what is this thing, that we can make any of the element of the triplet to be the twice minimum plus 1. Okay. So now if this is a important thing, we have to remember it, and then we will proceed. So what we will do here? Here, if we choose a certain index, let's say this, then the minimum value left it. The minimum value will be 0. Okay. So put the minimum value 0 here. Then what we will get, that we will make it to 1 at max. So we will make 1 0 and 0. Okay. So now if we take this element, this index 0, so what we will do, that again go to this condition. What is the minimum now? Now the minimum is 0. Or okay. So again it will be converted to 1. Okay. The now we will get 1 1 and 0. Okay. And up to which we have two steps. Okay. One step and two steps. Second step. So now what we will do now, if we check 1 or this one, we cannot increase this one or this one, because it will not hold true for any of the conditions. Because if we increase by 2, then it will then the pair of 0 comma 2 will not satisfy this, or 3, or obviously the greater values will not satisfy for this condition. So now what we should see here, that what we can increase, now we can increase the 0 only. Okay. So 0 can be increased up to which value? Okay. We can increase 0 to 1. It is okay. It is okay. Okay. So we can increase by 2. Okay. It is okay. We can increase it by 3. Can we increase it? Yes, we can increase it, because if we put 1 put the 1 here, the minimum value here, because the left out portion, then 2 into 1 plus 1, then it will be 3. So the maximum value can be greater than, or sorry, less than or equal to 3. So we can increase the 0 up to 3, and now what we'll get? We'll get 1, 1, and 3. So there it is our third step. So now if we again try to increase, so what will increase? We, let's say we increase any one of them, because now we cannot increase the 3 again, because 3 is at its maximum energy level for this triplet or this condition. So we can increase 1. Okay, so so how much amount we can increase? So again, in the left out portion, the minimum value is 1. So we can increase the 1 to be 3 maximum. Okay, so it is 3, 1, and 3. And then it is our fourth step. And then what? Then if we do such thing that we now what we can increase? We can increase 1 only, because the 3 and this 3, it is in their maximum energy level. So for 1, the minimum here are 3 and 3. Okay, so minimum is 3 here. So what, up to which amount of level we can go? We can go to 3 to 4. We can go to 3 to 5. We can go to 6. We can go to 7, because we can go to 2 into minimum plus 1, which is 7 here. So we can go to up to 7. But what we need? We need to make it 5 comma 5 comma 5. Okay, so what we'll do? We will make the 1 into 5. Okay, we have made it 5, and there is 3, and there is 3 again. So again, what we can do now with this 3? We can increase the 3 up to 7. And what we will do? We will increase up to 5, because we need 5. Okay, uh, so it was our fifth step. And in the sixth step, we will increase to 5. So this is 5, 5, and 3. So in the last step, again, we will increase this 3 to 5. So 5, 5, and 5. It is our seventh step. So thus we will get our triplet, desired triplet, which we want. So basically, if we observe a pattern in the uh, result, so we can see here. I will show you. So if you see, what are the in outputs for the certain inputs? For 1 it is 3. For 5 we have calculated, it is 7. For 14 it is 9. For 2025 it is 23. So basically we have to observe something. If we observe this, so you will get a pattern. So what is the pattern? So for 1, we are getting 3. Okay, so for 5 we are getting 7. For 9 we are getting uh, okay, sorry. For 14 we are getting 9. And for 2025 we are getting you can say 220, it is 23. Okay, so basically what we have seen, that to make this 5 555 triplet, we need 7 steps. So if we wanted to make the 6 comma 6 comma 6, how much steps we should need? So basically, in that case also, we should need the same 7 steps, because what we will do that in here. So in that case, uh, if you can see that what will happen in this case. So in this case, all we will start from there, 0 0 0, and we will increase our 1 0 0, and then again 1 1 0, then again 1 1. and 3, and then again 3 1 3. Okay, so now what we can do here, we I have told that we can increase the 1 up to 7. Okay, so up to 7 means that we can increase it to 6 only. So we will increasing the 6, and then 3 will be 6 this step, and then in this last step there will be again 6, and so that will happen for 7 also. Okay, so and if we take for 2, what will happen, that 0 comma 0 comma 0, we will increase it to 1 comma 0 comma 0, in and again 0 will be 1, so 1 1 0, and this 0 will be 2. So basically 1 comma 1 comma 2, and then this will be 2, this will be 2, and this will be 2 in the two steps, next two steps. Okay, so we are getting the value of 2 in what steps? 1 2 3 4 and 5 steps. Okay, so same will be for the 3, because uh, what we can see that uh, here is there is a pattern that for up to a level, that if you can say that 2 to the power k minus 1, let's say it is 3, which is 2 to the power 2 minus 1, our answer is will be 5. Okay, and if we, let's say for 5 also, the answer will be 5. For 6 also, the answer will be 5. The 7 also, the answer will be 5. But for 8, uh, it changes. Okay, so for 8, it increases uh, from 7 to 9. Uh, how can we see that? We can do it on your own. So basically, we will now increase it again 1, 1, and 0, uh, 0, 1, and 1, and 1 and 0, 1, 1 and 2, and uh, 1 1 and 3, and okay, and 3 can say we can go to 7. uh, Sorry, we can go to 3 1 and 3, we can go to 3 3 7 7, we can go to now 8 7 7 8 8 7, and 8 8 8. So how much steps we need? One step, two step, three step, 4, 5, 6, 7, 8, 9. 9 steps. Okay. So for 8 it is 9 steps. For 9, same, there will be 9 steps. For 10 there will be 9 steps. For 11 there will be 9 steps, up to which, up to the 15 there will be 9 steps. Again in the 16 there will be some increase. Okay. So here you can see a pattern. Okay. So what is the pattern, that for a value of uh, you can say 2 to the power k, some 2 to the some power of 2 to the power k to 2 to the power k plus 1. Okay, so let's say there it is 2, and, minus 1, there it is 2 to here we can see 2 to 7. So 2 to 7, there is a same value, which is 5. So if we clearly observe here, so what we'll see, that uh, or you can say that k minus 1, okay, so what we'll see, that so here k is equals to um, 2 here. So what is 5? So 5 is 2 into k plus 1. Okay, that is correct. So again for that part also, in this part also, what is there, that 2 to the power k minus 1 to 2 to the power k to minus 1. It is this value 9. And here, what is the value of k? The value of uh, sorry, I think I have made a mistake. So there was not 5, there will be 7. Okay, so what was there? There it was 2, and it was 4, and it was k equals to 3. Okay, so now it is okay. So basically here also, for 2 to the power k minus 1 to 2 to the power k minus 1 equals to 9. uh, Here the answers are 9. So where the value of the k are 4, so it is 2 into k plus 1. So basically what we can see, that for value that for a range of the values, that 2 is 2 to the power k minus 1 to 2 to the power k minus 1. For this range, the values are 2k plus 1. Okay, and what is the value of k here? So if we say that what is the value of k here, if we calculate that, so you will get that k, the value of k is the log value of that number. You can say that the number is, let's say the number is, it is m plus 1. Okay, so if we check in some test cases, so you can check also for 5, you can say that k will be log of 5 plus 1. So what, and it will be the floor value or integer value. So what will be the value here? 6 log 6. So it will be 5. Okay, so sorry, uh, there will take the seal value. Okay, so what will there? So there will be something 2.53 or something like that. So that the seal value will become what? The seal value will become 3. So here the k becomes 3. So it is 2k plus 1. Okay, so what we are getting, that we are, if we take the seal value of log m plus 1, where m is the number which we are given, or the energy level x, let's say. So then the answer will be 2k plus 1. Okay, so now how can we code that? uh, I will share my code here. Okay, just let me take a second. So Is it visible? Is my code visible now to all? Okay. So basically, what we will do, we will just take first the t, which is the number of test cases. So for each test cases, we will take input n, and then we will calculate the num, which is our k value. Okay. So what we were calculating? We were calculating that the num is log of x plus 1 and C of that. Okay. We are calculating the seal of that log of x plus 1. So now we can calculate it in some in this pattern also, that we are seeing up to which time the n is not it is greater than 0, and we are dividing it in each case, and we are increasing the num. So basically what the num gives us, or the k gives us, it gives us the number of bits it holds, the number holds. Okay. So now we get the number of bits, or you can say the k value, and we will output the 2 into num plus 1. Okay. So if you want, I can run it. So for, let's say, one test case for 5, it is giving 7. Okay. So you can say that it is running. Okay. So now we will proceed to our second question. Okay. That is Fibonacci cubes. Okay. So it is a good question. You can read that there is something called Fibonacci number. I think you should know about the Fibonacci number. It is a good thing in the math. That what is the Fibonacci number? Here is the definition, that the Fibonacci number are, you can say that it is the series of numbers, that is, if let's say f1 is 1, f2 is 2, then for every fi, which is where I is greater than 2, that will be the sum of the previous two values. So basically, each and every value of that in the series of Fibonacci series, it depends on the previous two values. Okay. And then now what we are given, that we are given n Fibonacci cubes. Okay. So what that means, that means that we are given something called, let's say, we are given three Fibonacci cubes. So we are given cubes with one dimension. Let's say it's width, length, and height is one, and second, for second cube it is the height, width, and length are 2. For the third cube, same, the height, width, and length will be 4. Sorry, 3, because 1 plus 2 equals to 3. And for the next, at that will be 3 plus 2 equals to 5, and so on. Okay. So now what do we want to do? We want that there are m empty boxes where ith box has a width of wi, and a length of li, and a height of hi. Okay. So basically, there are m boxes, and with their dimensions given. For each of the m boxes, you need to determine whether all the cubes can fit inside that box. The cube must be placed in the box following these rules. Okay. So what you want to do? You want to fit the Fibonacci boxes into the boxes you are given with the dimension. Okay. So there are some rules. We can read it. The cubes can only be stacked in the box such that the sides of the cubes are parallel to the sides of the box. Okay. So there is a condition that we should keep the cubes in such a you can say in such a form in the box, that the sides of the cube must be parallel with the uh, box itself, which is given here, the empty box. Okay. So every cube must be placed either on the bottom of the box or on the top of other cubes in such a way that all space below the cube is occupied. So now what does this mean? It means that every cube, you can place either it to the at the bottom of the box, or the empty box which you are given, or above any of the uh, existing cube which you have placed earlier. Okay, so and a larger cube cannot be placed on top of a smaller cube. Okay, and there is also a condition that you can put only smaller cube on top of a larger cube. So basically, what we have to do, that we have to return here we have to return a string. Okay, so that the string which will consist one or zero, and what the one and zero will denote. The one will denote that it is possible to keep the n Fibonacci cubes in that empty box, and the zero denotes that it cannot be. Okay, so if we see a test case, you can say the first test case, which is there are in Fibonacci boxes. So you can say the five Fibonacci boxes, and there are four empty boxes. Okay, and their dimensions are given here. So okay, so now it is the output. So basically here there is said that only this part 9, 8, and 13, this part only, that is capable of consisting all the Fibonacci boxes given. Okay, so this is a visual representation here. If you want better understanding, so now let's say that we are given n Fibonacci boxes. So let's say n is something as the test case. Now also we are taking n equals to 5. So what will be the dimensions of the boxes? Okay, the cube. So the cubes will be of 1, then 2, then 1 plus 2, that will be 3, then 2 plus 3, that will be 5, then the last will be 3 plus 5, that will be 8. Okay, so we are having the cubes with dimension 8, 5, 3, 2, and 1. And what we have to do, we have to fit them in an empty box such that their sides are with the parallel with the empty box, and there is the each and every smaller box is on the top of the on a larger box. Okay, so what we will do here, we will first you can say that if there are a empty box, how can we check that it can fit all the boxes or not? So if we think it greedily, then we can say that we will first check for the maximum amount of the uh, dimension, that if it is fit in the box. Okay, so how that will fit in the box, then the condition will be the, let's say the length, there is a b and c, these are the dimension of the empty boxes. So a must be greater than or equal to the 8, b must be greater than or equal to 8, and so c must be greater than or equal to 8. Okay, so basically what is told here, if we keep that cube with the dimension 8 here, what must be done? Then this condition must hold true. Okay, so now we get that. And if we see something else, that is that the other boxes, this, how can we put this in the box? Okay, so we can put this on the top of the of this largest box. Okay, here, or if there was some space here, then we can put here also. So basically if we will if we see the question in a certain understanding, that we will keep the height as max as possible. Okay, so we will assign the maximum amount of dimension here as a height, because we want that we will stack the boxes one on another. Okay, so in that case what will happen, that if we see that there are these boxes 8, 5, 3, 2, and 1, so what must be the minimum height that it will occupy all the boxes? So the largest height was that 8, so let's say it is the 8 height. So there will have something extra height that will consist all this
4 elements. Okay, so what must be this height? So this must be the height which is maximum among them. Okay, so maximum among them, that means 5. So that means at this height must be at least 5, so that we can occupy at or we can occupy this all these boxes in that hollow space here. Okay, as we can see that it is our height which is the maximum. So basically again, if we consider this condition, then let's say this is A, B, and C, and let's say it is in this condition A, B, in this here in so okay, then C will be our height. So what criteria should C follow? Okay, so basically we already know that A must be greater than 8, B must be greater than 8, which is the maximum value among all the n Fibonacci boxes. Okay, so thus the condition A greater than equal to 8 and B greater than equal to 8, it must hold true. And also as we want the height, uh, we are keeping the height as the maximum value of the dimension, as we are stacking all the boxes one on another, then C must be at an amount that it consists of the uh, first and second biggest cube. Okay, so what are the first and second biggest cube? That are you can say Fibo of n and plus Fibo of n minus 1. Okay, here what is that? Here it is 8 and 5. Okay, so what is that? Here it is 8 plus 5 equals to 13. So we can say that if there are three dimensions A, B, C, where it is, we can write it like that. This. So what criteria should hold true? The criteria will be A greater than equal to 8, B greater than equal to 8, and C greater than equal to 13. What means that key A must be greater than equal to the maximum Fibonacci box, that is Fibo of n. B must be greater than equal to Fibo of n, and C must be greater than equal to Fibo of n plus Fibo of n minus 1. Okay, so now are we sorted or not? Uh, uh, have we done everything? Yes, we have done everything, because it ensures that the empty box can contain all the Fibonacci boxes. How we can make sure that? We can make sure thus that uh, the diamond, let's say the number here, the ith Fibonacci number is the sum of previous two values. Okay, 3 and 5. So we are sure that if we see it from the top view, okay, from the top view if we see it, then let's say it is the box 8. So the smaller values, let's say 5 and 3, how they will be fit in here? They will fit like that. Okay, here it is the 5 5, and here it is the 3. Okay, because here the 3 and 5 make the 8. Then how the uh, left over 2 and 1 will fit here? So 2 will fit here like that, this, and 1 will fit here like that. Okay, so what we can see, that if we consider that it consisting it is enough, there is enough height for them to be adjusted, and there is enough width and length, which is the maximum uh, dimension among all the Fibonacci boxes. So that will be the criteria. Even say from that we can ensure that the empty box will contain all the Fibonacci cubes. Okay. So from now what we can see, that let's say we are given the dimension A, B, and C. First, what we will do? we will make them sorted order. Let's say the sorted order is the C, then the maximum amount, okay, the maximum element will be greater than equal to FIBO of n plus FIBO of n minus 1, and the left two other amounts, the two other values, they must be greater than equal to FIBO of n. So if now we check for the test cases here that we are given, that 5 comma 4, 3 1 2 10 10 10 9 8 13 14 7 20. So here what is the output here? The output is 0 0 1 0. That means there is 0 0 1 and 0. That means that it holds true, it holds false, false, false. Okay. So now if we check our answer, that what is happening. So for this case, we want that the maximum of these three elements must be the maximum. The maximum must be the maximum is here, that the maximum must be greater than equal to uh, FIBO of n plus FIBO of n minus 1, and the left two other must be greater than equal to FIBO of n. So what is here FIBO of n? The FIBO of the FIBO 5, which is here you can say 8. Okay. So what is there? The maximum number which is 3, it must be greater than equal to 8 plus 3, that is 13, and left 2 must be greater than equal to 8. So is it hold true? No, it doesn't hold true. Okay. So again for this case, the maximum element which is 10, 10 must be greater than or equal to 13. Okay, 10 must be greater than equal to 13, but there is which is false, so it will not hold true again. Then again that will be 0. Then if we here if we go there 9 8 and 13, so there the maximum number is 13, and 13 will be greater than equal to the value 8 plus 5, that is 13. Okay, so the first condition holds true, and then second 8 and 9, the both of them are greater than equal to 8. Okay, so basically this also holds true. So both the condition holds true, then it is 1. We can confirm it. And in the third and the fourth and last case, if we see the maximum amount which is 20, it is greater than equal to 13. Okay, but the 14 it is greater than equal to 8. Okay, but the 7, is it greater than equal to 8? Not, it is not greater than equal to 8. So it will be again 0 or false. So what we will do in our code, we will firstly calculate the Fibonacci numbers or the Fibonacci series. What will be 1, 2, 3, 5, 8, and 13, and something. It will tend to let's say it will tend up to 15 elements, because here we can say that the n must be greater than equal to 2 or less than equal to 10. So up to 15, the calculation will be fine. So what we will do, we will calculate the Fibonacci number in the series, and then we will just take the input of the dimension of the boxes, and we will check this condition if it holds true or not. If this condition holds true, then there we will put a 0. If we will put a 1 in our string, or otherwise we will put a 0 in our string. Okay, so now if we go to the code, then this is the code. So you can see here that what I am doing, that in the vector dp, I am storing all the Fibonacci numbers. Okay, so we there dp of 0 is 0, dp of 1 is 1. So I am calculating all the Fibonacci numbers up to 15 terms, and then I am taking the input that t, and then for the each test case I am taking the number n, which is the number of the Fibonacci cube, and m, which is the number of boxes. Okay, empty boxes. So we are taking a string that is our that we will return at the last. Then in every iteration from d0 to m, we are taking input of these three dimensions of the boxes m box. Okay, so these are the dimensions, the v0, v1, v2, and then what we are doing, we are uh, sorting them. Let's say that becomes, after sorting, then it becomes a comma b comma c, and here if it is a comma b comma c, then c must be greater than equal to uh, the you can say fibo of n and plus fibo of n minus 1. And what is fibo of n plus n minus 1? Fibo of n plus fibo of n minus 1, that is fibo of n plus 1. Okay, so basically c must be greater than equal to fibo of n plus 1, and a and b, they must be greater than equal to fibo of m. Okay, as I am taking here as a zero based indexing in the Fibonacci DB array. So there I have put n plus 2 instead of n plus 1, and n plus 1 instead of n plus 2. Sorry, n plus n. Okay. So basically, if it holds to this condition, which I have recently shared, then we will add 1 here in the string, answer string, and otherwise we will add a 0 in that string. Okay. So after that, we will just output the string. If we check, let's check. Let's see, we are getting one input, and it is uh, 5 4 dimensions, and MMA, then 3 1 2 10 10 10 9 8 13 14 7 and 20. So what will be the output? The output will be 0 0 1 0. That is needed. Okay. So it is okay. Then the question is completed. So I think you have understood this. So we will go to our last question of this discussion. Okay. So the last question, what it states that equal values. Okay. So you are given an array a1, a2, dot 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 an, consisting of n integers. In one operation, you are allowed to perform one of the following actions. Okay. What is the action? Choose any position I and make all the elements to the left of I equal to ai. Okay. So we are, what we are doing, we are taking one index I, and we are making the all the elements at its left side to be ai, and that is the assigning the value of ai to sorry equal to ai. Okay. So basically, there is a cost in that operation. The cost is I minus 1 into ai, which means the number of terms we are converting to ai into the value of that term ai. Okay. So again, the another action what we can do, it is that we choose a position in our index I, and we make all the elements to the right of I equal to ai. Okay. So that will also cost some as an operation, that is n minus I into a. So basically, it is also the same that we will that it will cost the number of turns which we have converted into AI into the value of AI. Okay, so here we have said that we know that the elements affected by an operation may already be equal to AI. So there is said that if there can be a possibility that any you can say that in the left side or the right side of the chosen index there may be some elements that is already been AI. So but it doesn't changes the cost. Basically the cost counting which was the formula that is it and it will remain same whether it converts or it is already same as AI. Okay, so it doesn't affect so much. You are allowed to perform any number of operations including zero. What is the cost to make all the elements of the array equal? So what is said here that we can perform any number of operations and we have to find the minimum total cost to make all the elements array elements equal. Okay, so here we will be given these array elements. So these are the if we check that, let's say to okay. So if we say, let's say it is the array 2, 4, 1, 3. So the most brute force or naive approach you can think of it is that we will take an index, let's say 4, let's say 1, first index 1 and the value is 4 and we will make the all the elements right hand side to be 4 and all the elements in the left hand side to be 4. So basically what we are doing, we are just choosing one index twice a time and we are making all the elements as equals to that element. Okay, so what will it will cost? It will cost as the AI, which is the value of that element into the length of the array minus 1, because we are converting n minus 1 element to be AI. Okay, so it is the basic naive approach, but it sometimes will not be okay. Okay, because why? If we take this condition or this array that is 7, 5, 5, 5, 10, 9, 9, 4, 6, and 10. So basically, for 7, there the value that will be always a 7 into that if let's say it is n, the length of the size of the array is 1 2 3 4 5 6 7 8 9 10. N equals to 10, so it will be n minus 1. The cost for making all these to 7 will be 1. For making all these elements to be 5, so now there's a twist. Let's say if we go by our basic naive approach, so that will be the answer that is 5 into n minus 1, that is what? That is 5 into 9, that is uh, 45. Okay, but but I can show you that I can get minimum answer than 45 for 5 also. How? That is let's say 7 5 5 5 10 9 9 4 6 10. So basically what we will do, we will take the leftmost element of the, let's say there is a chunk of 5, because there is a chunk of 5, so we will take the leftmost 5. Okay, and we will take the rightmost 5. Okay, so there is two pointers, one which points to the leftmost element, the leftmost frequency of that element and the rightmost of the element. Okay, so then what we will do, we will make the action that is we will make the left hand side of the element all the elements to be 5 for this pointer. Okay, so we will make 7 to be 5 and we will make the right right hand side all the elements to be 5 for the rightmost uh, value of the chunk. Okay, the rightmost index it is the 5 it is so basically we will make all these values to be 5. So now what will be our cost? So now our cost will be there will be 5 and there will call the cost will be 1, 2, 3, 4, 5, 6, 6 elements. So 6 into 5 that will be 30. So that will be 5 plus 30 that will be 35. So what we are saying that if we get a chunk of a same element, there is a you can say this. So what we will do, we will do the first operation, which is that uh, we will make the all the left hand side elements to be the same element or AI. Okay, for the leftmost element, for the leftmost occurrence or index, and we will do the second operation, which is that we will make all the right hand side elements to be as same as the value of that element. We will do the second operation for the rightmost occurrence or the rightmost index or the chunk that is here. So basically what we will do, we will use here the two pointer approach, where we will find any chunk or any for any number that by this logic that we will find the leftmost chunk of occurrence or the leftmost index of that chunk and the rightmost equivalent index of the chunk, and we will calculate the value. Okay, so how the value will be calculated? Let's say now there is array, let's say here also 7 5 5 5 10 9 9 4 6 10. Okay, so for every chunk or any element, what we are doing, let's say there we are pointing here and here, there is I and there is j, and the index are 0 1 2 3 4 5 6 7 8 9. So basically what will be the cost to convert this part or the left hand side? So that is ai into I, which is the index, that is same, that is 5 into 1, that is 5, and it is the AI. And what is this element, what is the cost of this part? So this part cost will be aj into n minus j. Okay, where aj and ai are same, so the total cost which will be ai into n minus j plus I. Okay, so we will calculate this part for each of the chunk or the element, and we will return the minimum value of or the minimum value as the answer. Okay, so I think it is okay, and now I will share the code with you. So this is the code here. Okay, so this is the code that we are taking the t, the number of test case input, and then n, then the array n of mention. Okay, so then we are taking the inputs and then we are assigning the answer to be the maximum long value. Okay, then we are taking the two pointer I and j, and then we are doing a while loop where j must go up to the last of the array. Okay, and when in each and every for each and every element here we will check if there is a chunk of element or it is a single element. Okay, if it is a chunk of element, then what we'll do, then up to the chunk it will I will increase the j uh, until this condition holds false. Okay, or this condition holds false. Okay, so now after this loop we will get the chunk by our two pointers I and j. So now what we will do, we will just do that answer equals to minimum of answer, and for that ai into n minus j plus I. Okay, and there is a small clarification, I think. uh, Here, here I was uh, telling you that there is j and there is n minus j. So it is not. It is there will be j minus one. But as we are taking the chunk, we in our code we are taking the chunk, and the j is increased to up to 10. Okay, because we are what we are doing, and until it is equals to a of j, we are increasing the j. Okay, so it will go up to the 10, then it will stop. So basically now what we will have now we will have that the uh, number of elements which will change, that will be the length of the array n minus j, that is the index, and thus it is our final answer, the minimum value of the answer. Okay, so now if I try to show you any test case, let's say we take a single test case. Or we can take all the test case also. Oh, okay, just let me copy the test cases. So these are the answers: 3, 0, and 35. And that is the correct answer. You can say here, see here, 3, 0, and 35. Okay, so this was the logic of the problem, and this was all the PCB for now. Hope you have enjoyed this session. Uh, we will meet in the next PCB of our course. Until then, happy coding. You guys can leave now.